Hello, everybody coming in.
Hello, Zvonimir. It's Randy.
Hello, Randy. I was thinking that's a familiar voice. I just couldn't see the video link as to who it was. Welcome.
Aha. Thanks.
How's the day?
Long.
The long, short week has been the consensus from the group here.
I forgot about it being a holiday on Monday because I had 4 hours of online meetings on Monday, which I spent more time with those people at the meetings than I did with my family on Family Day. I suspect a lot of people worked on Family Day though.
Yeah, absolutely. And I guess it depends on the province that you reside in. I think the holiday itself is a different name in different province.
Yeah, I want to celebrate Louis Riel Day as a renegade. So
there you go.
Not in that jurisdiction.
Awesome. Hello, everybody else coming in. Feel free to chime in and tell us where you're coming from.
Hi, my name is Robin, and I'm in the Sunshine Coast, which is just outside of Vancouver, BC, Canada.
Awesome. Welcome, Robin. Thanks for joining us.
Sorry, Robin, where did you say you were outside of BC?
Well, I'm in BC, Sunshine Coast, near the town of Gibsons. It's just
oh yeah, Gibson's Landing. Yeah, okay. Yep, nice place. I hear you had a little snow lately.
Yeah, just a little. Doesn't last around here.
No, it's true. Yeah, that's right. I used to live in Vancouver, so if it snowed, you just waited until it melted instead of shoveling it.
Boy, isn't that nice? Anybody else would like to say their hellos to the crowd?
I can say hello. Hi. Can you hear me?
Yes.
Yep.
Hello.
Okay. Hi. My name is Joseph Webby. It's my first time attending this session. I'm a tech entrepreneur, co-founder of a company called Dimeless. We're building a B2B AI marketplace, kind of like the Shopify for vetted AI teams. I was living in Toronto, finishing up my artificial intelligence master's program at Queen's. Now I'm in the US, waiting to come back because the borders are closed. But found out about this group through Professor Matthew Taylor.
Oh, that's
awesome.
Great. Thanks for joining, Joseph. Yeah, I know lots of people doing international travel for a variety of reasons, and it's become way more complicated than it need be, but that's the reality of the world.
Yeah. Thanks.
Awesome. Well, we're excited to have everyone join us today. I think the team is finishing up letting everybody be checked in. So thank you all for your patience as we're slowly ramping up the meetup. But now that everybody's in, this is an official welcome and hello. Thanks for joining us. This is the February edition of the AI Meetup. My name is Zvonimir and I am the Marketing and Communications Associate here at Amii, tuning in from Edmonton, Alberta. For those of us joining us again, welcome back. And for those of us joining us for the first time, welcome for the first time. Amii is the Alberta Machine Intelligence Institute, one of 3 centers of excellence as part of the Pan-Canadian AI strategy, with a history reaching back to decades of world-leading AI research and training that has put us in a position as one of the global leaders in AI and ML. So whether you are involved in a business, or you're a student, or just looking to get involved in the AI community, Amii has a whole host of programs and resources to support you, and we'd love to connect. So feel free to find us at amii.ca or send us an email to hello@amii.ca to learn more. But a few housekeeping notes before we get started. This meetup will run about an hour and a half, and it will be recorded. So you will be able to review this meetup on our YouTube page as soon as possible. So feel free to tune in, or if you can't stay with us the whole time, that's okay. There will be a recording available to view at your leisure. So, but we are excited to see all of your faces, and we encourage you all to keep your camera on throughout the presentation so we can gauge your reactions. And as we continue to improve these virtual events with each iteration, you can expect an email after this meetup with an incredibly short survey. This is a survey just to let us know how we did, what we can do better. So we wish to hear your feedback, and it will help us out a lot. But housekeeping aside, we have two great presentations for you this evening. There will be a quick Q&A session at the end of each presentation for any questions that you may have for our presenters, at which point you will be able to unmute your microphone if you want to ask your question verbally, or alternatively, feel free to pop your question into the chat box at any time. So without further ado, let's jump right into the content. So please welcome our first presenter, George, who is Amy's MBA intern. So welcome, George. Thanks for joining us today.
Excellent. Thanks, Ron. First, let me share my screen. Can you see the screen? Like it should be a presentation.
Yeah, looking clear, right? George, thanks.
It is? Okay, great. Yeah, so welcome everyone to this presentation. I am George. I'm an MBA intern here at Amii. And also, apart from this, my main role is actually, I'm also a full-time MBA student at the University of Alberta. So today I'm going to talk about artificial intelligence in the agriculture sector. So this would be the agenda for this presentation. We would be looking at an overview of the agriculture sector with focus on Canada. Then we would be looking at the various challenges for agriculture in general, and then talk about AI in agriculture industry to give a brief outlook, followed by some important use cases. And finally, I will briefly talk about the REMI AI in agriculture program conducted by Amii. So here is an overview of the Canadian agriculture industry. I can see like this is maybe a lot of information to grasp, but let's try to break this down and we shall see. So on one side, on the left, so we can see that we have the primary agriculture sector, which talks about the farms, which are mainly concentrated in Western Canada and also in Southern Ontario. And it covers about 7% of Canada's land area. On the other side, we have the food and beverage processing industry, where you can see the main industries are the meat industry, which constitute 25%, followed by the dairy, beverage, and grain and oilseed milling. And in total, this sector employs about 2.3 million people as per 2018 data. And that is, it provides 1 in every 8 jobs in Canada, and it accounts for about 7.4% of Canada's GDP. So agriculture has been traditionally a large sector, but there are quite many challenges for the sector in the near future. Firstly, the global population is expected to rise to about 9.7 billion by 2050. This means that there will be an additional 2 billion people on this planet to feed, which will require the present global agriculture output to be increased by at least 60% to meet the demand. And if you see, the agriculture production has more than tripled between 1960 and now. Now the world's population has grown from 3 billion to 7.7 billion presently. So while technology has played a vital role in this in the form of machines, various pesticides, fertilizers, etc., much of the gains can be attributed simply because we were plowing more fields. I mean, taking in more land. But we will have to be more resourceful this time around, as these natural resources are limited, and also they are being used for various other purposes also. And also, we'll all agree that the effects of climate change is making the weather unpredictable. which affects the agriculture output and is certainly a big threat to food security. And the workforce in agriculture is also steadily declining as people are finding employment in other sectors, and the present workforce is aging. So mechanization of farms has played a big role in countering this problem, but now there's a need to take an extra step. So what may be the answer to all these problems? Enter artificial intelligence. So imagine swarms of drones buzz over the fields, bringing live visuals and analysis to the farmer, and robotic vehicles that zap weeds with extraordinary precision and picking the produce while the farmers relax and oversees the operation. It sounds very futuristic, right? But my dear friends, we really need not let our imaginations run this wild, because this is not an excerpt from any science fiction or a vision from the future. Rather, we are talking about technologies that have been developed in the present. We have already stepped into the future in a way. Today's agriculture is rapidly revamping into a high-tech enterprise. In fact, in the last 20 years, with the advancement of computing power and the development of GPS, electronic sensors, among other new tools, AI is steadily emerging as an essential part of the agriculture industry's technological evolution that powers innovative industrial applications and is an answer to our growing needs while ensuring a sustainable future. And let us now take a look at AI in agriculture industry to get an idea of how promising this industry is. So according to a market study report, the world market size for AI in ag was 852 million in 2019. So this industry is set to see an impressive 25% growth rate CAGR till the end of the time window that was considered, in this case is 2030, where the market size is estimated to reach around 8.4 billion. At present, North America is the largest region, largest market by region, but the Asia Pacific region will be the fastest growing from 2020 to 2030. And US and Canada are the two biggest markets by country. And as per projections, they will continue to dominate in 2030. So you can see the grass is definitely green for AI in agriculture industry. And now let us look at some important use cases of AI in ag, where AI is being used to solve traditional farming solution problems. The applications that we'll be going through are yield prediction, disease detection, weed detection, and livestock management. And most of these fall under the umbrella of what is known as precision agriculture. Firstly, yield prediction. So yield prediction basically means to predict the crop output. As you know, traditional methods of predicting yield require much expertise and know-how from the farmers, as it takes years of experience to get that knowledge. Also, it's very difficult if you see there are so many number of variables that you have to account for, right? And these all influence the output. And especially if you'll all agree, the weather conditions, which are increasingly becoming very unpredictable. Artificial intelligence applications have been developed that use various data as inputs to accurately predict crop yield and also the time of harvest. These can have a number of benefits. Firstly, corrective actions can be made to the soil inputs like fertilizers, pesticides, and irrigation, seeing the yield trends. Also, since the time of harvest can be accurately predicted, farmers can plan labor and other resources that they will need during the harvest to gather the harvested crops and take them to market. Thus, this will help save a lot of effort and costs. Looking at a very basic workflow diagram of how a machine learning model is created for yield prediction at a more broader level, in this case, at a province level, Remote sensing data and geographical information, along with ground truth crop yield data from previous years, are fed into a convolutional neural network algorithm. And the result is that we get a prediction of the crop yield. And one of the more useful applications of prediction at such a broader level is to determine where the food aid might be required if yields are predicted to be very low. And if you look at a more closer level, at a farm level, handheld and vehicle-mounted proximal sensing techniques can be used for surveying soil and crop variables, which are responsible for variations in crop yield. And these proximal sensing allows real-time site management of soil inputs like fertilizers, pesticides, and irrigation, and provides ground data to map crop areas, which can be then used for precision agriculture purpose. The model that is trained for such an application uses historical data of yield, soil, weather conditions, and various algorithms, including linear regression, k-nearest neighbors, and support vector regressions have all been used for building such models. Next, we come to disease detection. Plant diseases, as you know, can directly lead to stunted growth, causing bad effects on the yields. An estimated 40% loss on yield can be resulted due to diseases, which translates to economic loss of about 20 billion at a global scale. And if you see, the traditional methods mainly rely on specialists' experience and manuals, and a majority of them are expensive, time-consuming, and labor-intensive. So therefore, like a rapid and accurate approach to identify plant diseases is required and will be very beneficial for farmers. This is where AI can help. Computer vision applications using deep learning models have been developed to detect various plant diseases. Smartphone-based AI apps could alert farmers and expedite disease diagnosis. So you can see from like on the screen that here's an example of how a disease detection model has been developed, in this case for a banana plant. I can quickly walk through the workflow diagram that shows the various steps in this process. In fact, it's applicable to any machine learning model development. So to train the model, first we need a large data set of images. In this case, close to 30,000 images of various sections of the banana plant, such as the leaves, the pseudostem, the fruit, the cut fruit section, and also the entire plant pictures itself were taken. Then these are labeled according to the diseases seen in them manually, and they were divided into various classes. Now that they have been labeled and we have a labeled data set, these images were split into training, validation, and testing data sets. In this case, the splitting was done in 70, 20, 10% between the training, validation, and testing data sets. Once that is done, our deep learning convolutional neural network model is trained on the images from the training data set, where it is like basically taught to recognize the images and the class of disease in which they belong to. And this fitted model is then used to predict the responses for the observation in the validation set. That is further used for like fine-tuning the model parameters. And finally, the trained model that we have then is tested with the test data set to determine the capability of the trained model. And once this model is said to be accurate enough, applications are developed and images captured on smartphones can be fed into the app, which can then predict diseases and it can recommend remedies. So what are the benefits to the farmer? Such applications help to facilitate early detection of diseases. So before it spreads beyond control, and timely intervention by the farmers will only help to control the disease spread. And this action will help prevent yield loss, and treating diseases at the beginning, as you'll all agree, will save costs on various chemicals that will be used for treating the disease. next we come to weed detection. So what are weeds? Weeds are unwanted plants in the agriculture field that competes with the cultivated crops for resources such as water, soil nutrients, and they can be host to various pests and also that cause crop diseases. Hence, it's very important to eliminate them. One of the common ways is to spray herbicides, but these traditional sprayers, like they can only spray the chemicals uniformly. Like they have blanket approach, despite the fact that the distribution of weeds is typically patchy. What this means is that there's a lot of wastage of valuable compounds, which in turn leads to increased costs, crop damage, pest resistance to chemicals, and contamination of products. But more importantly, it has adverse effects on human health and the environment. And it is interesting to note that farmers report around spending 65% of their total expenditure towards herbicides or weedicides for weed control. So how has AI helped in weed management? AI is being used to power automated sprayers, spraying systems which are used to detect and spray precisely on the weeds, helping to eliminate the manual work and also reduce the use of weedicides significantly. Here I have a video for you, which I found to be very useful, and it's I think it's pretty useful. Let's take a look. Yeah, like I saw in the chats that we can't hear. Apparently, the sound wasn't important. It was just the visual, so it's fine. I couldn't do anything in between. So we didn't miss out on anything as such. Anyways, me. So as you saw, like about 26 billion is spent on weedicides worldwide every year. And as you can see, these AI-powered sprayers could significantly reduce that expenditure on herbicides, even up to 90%, and correspondingly negating the adverse effect on environment and, more importantly, on human health. This looks really promising, isn't it? Next, we come to livestock management. This is very important in the Canadian context, as we saw in the agriculture sector outlook that meat and dairy industry constitutes about 40% of the entire sector. Here we'll be looking at two applications in livestock management. The first application is cattle weight estimation. An interesting fact to all people is you may be even aware that Canada is one of the largest exporters of red meat and livestock in the world. It exports around 40% of its beef and cattle production each year, and it is shipped to 65 countries. Anyways, live weight measurement of cattle is needed for monitoring cattle growth. This relationship between live weight, milk yield, and feed intake can be taken as a criteria for organizing the care and nutrition of animals in modern keeping conditions. The traditional methods uses manual measurement methods, which can be very time consuming. AI applications have been developed to identify the breeds of cows and estimates its various characters like live weight. This is yet another flow diagram of such an application. Here, the combination of the cameras is used to determine the 3D coordinates of the object, in this case, the cows, using the principles of epipolar geometry, from which the cow size is determined, and also the cow's breed is identified. And this info is fed into a multi-layer perceptron model, which is a type of artificial neural network with several layers. And it is used to obtain an estimation of the cow's live weight. And this method has several benefits to the farmer. Firstly, it saves a lot of time and effort, as manual calculations takes much time and effort is taken to keep the cow still. Also, the estimation helps in managing optimum weight, as underweight cattle potentially means nutritional deficiency or perhaps the onset of some diseases. But more importantly, it is a contactless method, which ensures that there is less intrusion into the habitat and the animals don't feel much disturbed. And now the second application is early warning for egg production deviation. Poultry farmers use data to monitor the production, the egg production of their flocks. So they frequently use a tool which is called the egg production curve to monitor the production. This helps them to detect problems, which means that there could be possible disease or any other issues. This curve, it can be affected by various factors such as food intake in both quality and quantity, water consumption, intensity and duration of light received, vermin infestation, diseases, and other handling or environmental issues. Machine learning algorithms can be used, can be trained to serve as early warning systems that will allow early detection of diseases. Here you can see a sample of the egg production curve. In this particular case, a support vector machine approach is used to identify problems. As some of us know, that support vector machines is a supervised machine learning algorithm, which is used to classify data sets into two different classes, which is separated by a hyperplane defined in appropriate space. In this case, however, the support vector machine algorithm is used to detect abnormality and predict possible dip in production. It may be of interest to note that that some of the features considered as inputs while developing the model include the genetic line of the birds, stochastic variations in egg production, daily and cumulative mortality, etc. And as you can see from the figure that you have the egg production curve, where the daily production is plotted, and the machine learning model is able to predict dips in production, and as you can see, a few days in advance, which acts as an early warning for the farmers, and they can investigate further into the matter. So what are the benefits to the farmer? So when it comes to diseases, an early detection tool is of vital information as it helps to detect diseases before it is spread to other animals. The early detection means that it prompts that we act in a timely manner and we take corrective actions, which in turn reduce the costs and losses to the farmer and also increasing the effectiveness of the treatment. And the problem can be tackled early. And yes, so we come to the end of it. As a conclusion, agriculture production, as you know, has come so far in this past decades, but there's a need to go to the next level. AI can certainly help humanity confront one of the biggest challenges that lie ahead, that is feeding an additional 2 billion people by 2050 and even beyond. While today's agriculture technologies and AI capabilities are evolving at a rapid rate, this evolution is just the beginning. The times are exciting, the possibilities are endless, and the future certainly looks bright, promising, and sustainable with AI. And with this, I end my presentation. Thank you so much for being such a patient audience. And before I end, I would also like to talk a bit about the REMI agriculture program. So Amii is accepting applications for participation in its Agriculture Spring 2021 cohort for the REMI project. The REMI stands for Reducing Emissions Through Machine Intelligence. And the REMI agriculture program is designed for companies from startups to small, medium, to multinational corporations to help progress along the AI adoption spectrum, while its focus is on greenhouse gases reduction projects. So the admission for the spring cohort, what I understood is open till the February the 26th. And the program guide can be found on the website. I think Zon will share that. Have you done?
Yep, already did. You're good, Jared.
Oh, you did. Oh, great. And yeah, so the program details can be found there. And if there's any interested participants, they can contact the Investments and Partnership Department through their email ID. And that's it from my side. If there are any questions, feel free to ask. I'll try my best to answer. Thank you.
Awesome. Thank you for that, George. Yeah, let's take a moment to receive questions from the audience. Feel free to unmute yourself or ask any questions that you may have in the chat.
Yes. Well.
Hello, William.
Hello. I'm just wondering for like the egg production deviation, you show like the graph and how the machine learning can grab the data, can figure out where there's like a deviation. But like, what if the graph is like more complicated because you showed a pretty clean graph, right? Because there's like 2 nodes.
Yeah, that's an interesting question. Okay, so that is something I wondered in the initial phases as well. On top of my mind, like there are various parameters that, like as I mentioned, regarding egg production, regarding the daily mortality rate, the daily feed that goes in. Those are all parameters that goes in. So that may all affect the production curve. So I think, yeah, that may be it, but it can be more. So I haven't gone through it very deeply, and I could check that out for you, William, and get back to you. Okay, but as far as I know, it involves these many parameters that are used as features, and they all influence the curve.
Okay.
Yeah.
I do want to like see it actually like in action, like in like more scenarios. It would be nice.
Yeah. In fact, yeah, I can share the link of the paper that I referred to you as well, and maybe you can take a look. And I can also ask my the technical experts here at Amii to have their views as well, if that helps.
Okay, looks like we have a question in the chat, and this might be a loaded question. How long would it take to train a robot for the purpose of agriculture?
Okay. Okay. So first, CC, right? CC, like, are you new to? That's an important question, I think, for me. So I'm new to AI. So if you are new to AI, I think I can answer this question. But if you are an expert, I think this is a trick question. But I'll try to answer this. So as you know, training machine learning models take a lot of data, right? It depends on the quality and the quantity of data. So if you have the appropriate data, I assume that it won't take much long. That is like my coming from a newbie in AI, that's what I can answer. But if there are any technical experts here, they may want to.
We have a few Amii people. Omid?
Yeah, this is Omid. Thank you, Josh, for your presentation. Yeah, as you mentioned, we need lots of data, and also like in terms of quality, we need data about different scenarios. So if that data is available, or if we can like have that data, then it wouldn't take that much to train the model. But this is the challenging part, especially if you're trying to use, for example, reinforcement learning in order to like do something regarding optimization or something like that. It might seem that like it's going to be it's going to take more time, because you will see like some new situations or scenarios. So then in that regard, it needs more time to like fully train your model.
Thanks, Umid.
No
I
problem.
think I answered partially also. So like, much time is taken in gathering data, and also I assume in also labeling the data, which also takes time, right? Yeah. Thanks, Umid.
Okay, we have a question from Paramita.
Hi, thank you. Great presentation, George. Really
Thanks,
loved
Paramita.
it. I heard a lot of interesting ideas. So I have a question for you regarding the weed and the disease detection that you were mentioning. My background is in botany, and and I know that there is quite a lot of like many diseases which have same symptoms. They look similar. But if you go deeper, you would find that one of them is probably a physiological disease. On the other hand, another is a pathological one. By that, it means one could be caused by a fungus. On the other hand, another could be caused because of a magnesium deficiency. So entirely different disease, though they look similar, and they would require entirely different ways of treatment. I was just wondering if using the computer vision and detection softwares and finding machine learning approaches, can it actually identify or differentiate between disease states based on just images?
Yeah, that's a good question. So how I see this as, so suppose you are saying like a disease looks similar on top, but the underlying cause is different, right? So how I understand these applications is that once like you take the photographs and live visuals, the data is fed into the application, and it gives you remedies. So at the top of my mind, I would assume that if a particular physiological condition is seen, and already if it's known it can be caused by two causes, I would assume that it will list the two causes, And then maybe you'll have to look into more depending on what you see as remedies and take appropriate action. So like, in short, it will give you the options like the possible remedies, and then you'll have to maybe see it further. So that may be like a more complicated situation, if I understand it correctly. Right?
So
Let me add something to Paramita's question. A good way to think about what data science can do to classify or categorize what is observed is to think about how humans are able to do that. So a good plant scientist will know where to look when the obvious symptoms that present themselves visually are similar, but one is suspicious about the relationship to cause of disease. That just means that the subject matter expert like you is going to help the AI expert like me or like George or like Omid to be able to look at and try to determine which factors are more closely related causally to what the symptoms are observed. So I think rather than ask the question about what George provided as an overview of deep learning methods applied to annotated or supervised data, the broader picture is how to uncover the causal correlations between what observes as subject matter experts. That's not different from diagnostic imaging than it is from plant science observations in that way. So I think that's one way to think about it, is rather than ask whether these broad methods can solve a problem, question is can those broad methods be informed by the kind of data that gets captured and labeled to be able to produce accurate predictions? So it doesn't contravene anything that anybody said. It just says that ultimately the complexity of the classification lays with the subject matter expert. I hope that helps.
yes, it did. Thank you so much, Randy.
Thank you.
So basically, the way I'm looking at it is there is the human component, the human who would be coming in to basically identify or determine the answer, and whatever the algorithm comes up with, and working together to see whether it makes a fit, as you talked about diagnostics.
Yeah, working together is important, but be cautious, because we already know that our machine learning algorithms can do better than humans in some cases. So the human subject matter experts, if you like, think of your role as a teacher is a teacher of someone who knows nothing about your subject area has the responsibility to lift their knowledge to the point where they become as expert as the teacher. They may indeed become more expert than the teacher just based on how well they've been taught. And so it's one of the things that's often ignored about the application of machine learning is some machines can do better having been taught in this currently primitive form of labeling data, can do better than the human. And so those are the exciting areas, right? Reduce the cost of doing that diagnostic classification to accelerate the identity of crop causal failure and so on and so forth. Also applies in the transformation from crop genomics to crop phenomics is what some plant, as you know, right, plant scientists talk about. Searching the space of the genomic configurations that produce heartier crops is also an AI problem, just like as it is at U of A in bovine genomics, where you search for the best configurations of genes in a hereditary graph of cows, for example, like George was talking about. Anyway, I should stop giving a lecture. Thank you.
Thank you so much.
Thank you so much.
So we have time for one more quick question before we move on, and this is one from Derek at Flatley. And Omid, maybe you can help with this one as well. For the AI use cases you presented, are there any publicly available data sources from Alberta or Canada that can be used here?
Yeah, does Amit want to take that question?
Uh, so these use cases are mostly, so correct me if I'm wrong, George, are mostly borrowed from technical papers, right?
Yes.
Yeah. So I'm not sure if we have like similar data sets available like in Alberta. And if this is the case, I'm not sure if they are willing to share with you, because like it's not something that publicly available or something that is gathered by like a federal agency or something like that. So it's not like a weather profile or something like that. So this is different.
Yeah, as an example, when I talked about, thanks, Amit. As an example, when I talked about the banana case, those images were obtained from different departments of agriculture in various countries, like in India, like some countries in Africa, etc. So yeah, it was like procured especially for that purpose.
Excellent. Well, thank you all for the lively discussion, this meetup. It's always lovely to see. And thank you, George, once again for the presentation this evening. Before we move on to the presentation from Intelius, this is a good time to take a moment and I invite you all to give a shameless plug and share with the group anything that you're working on in the AI world. If you have any exciting news on behalf of your research or your organization, whether you're hiring, looking to be hired, or if you're looking for mentorship, let's take this moment to raise awareness of what you're looking for and what you're up to within the community. So if anybody wants to take a quick moment to share an opportunity or an ask, now is your chance.
I have one to share. So my company Pathway Intelligence has developed offline RL systems, and so I'm looking for for places to apply it in industry and research. Yeah, offline RL. So my name is Robin Chauhan. I'm with Pathway Intelligence here in Vancouver, BC. Thanks.
Awesome. Thanks for sharing, Robin. Last chance to share. Okay, let's move right along. I'd like to now welcome Farnoush and Wayne from Intelius.AI. Please join me in welcoming them. Intelius.AI is based out of Calgary, and they have just recently celebrated their third birthday. So please, hello, Farnoush and Wayne.
Hello, thank you guys. Thank you for your time. And George, great presentation. I learned a lot around agriculture, so good job there. Yes, I think we are a small entity just started in Calgary about 3 years ago. I'm Wayne Madhlangobe, I'm one of the co-founders, and I work as a CTO. So I'm gonna have Farnoush introduce yourself. So before I do that, I need to share my screen here. If I can find the share screen.
You can see that the green bottom, I guess.
Yeah, I see it now.
Yeah. Hi, everyone. Maybe I can introduce myself while you are putting the slides up. So my name is Farnoush Farnia. I am co-founder and CEO at Intelius.AI. And myself, I have a PhD at industrial engineering and experience in delivering and managing larger scale AI products. So that's my background. And I know, Wayne, have you able to figure out how to pull up?
Yeah, can you guys see my screen?
No.
No? Okay.
Nothing on my end here, Wayne.
All right, let's try again. How about now?
Yeah.
Yeah, looking good.
Awesome.
Okay.
Good. Thanks, Wayne. So I'm going to walk you through our services and our delivery approach, and then hand off to Wayne to walk us through our AI, our main AI product that we are working on and how we do model deployment. So at Intelius, one of our services is providing AI consulting and advisory. And our role is to make sure our customers are having guidance on what and when they need to implement AI in their businesses. And our focus is making sure we drive value for our customers while minimizing their risk. We are also helping our clients to build customized AI products. We focus on building the products for the users and make sure we follow best AI practices. We also offer complementary services to bring a cost-effective AI architecture that's able to accelerate the AI journey for our clients. And in terms of delivery approach, we offer 5I approach. And the foundation of this approach is to make sure we de-risk any AI development. So we kind of initiate with AI discovery, and where we kind of brainstorm the challenges with the business and identify the use cases where can be solved using AI. And next, we kind of ideate the solution and define the blueprints of the use case. Then we invent the minimum viable product that's able to be used and tested by the users. And once we kind of validated the MVP and observed the value, we move to the implementation phase when we industrialize and scale up the solution. And also, finally, we kind of transfer the ownership of the models to the business. And also, we are here to support if any of the clients require us as an ongoing support. So from our experience, I specifically want to talk about this, is that AI blueprints usually get missed in the process. Therefore, we kind of propose AI blueprint canvas that help us to address some of the key questions. So we kind of need to understand what is the objective and what is the problem that we are going to solve. We need to identify what is the potential value, and both from the quantitative and qualitative perspective. And from the analytical side, we need to understand what is the problem solution look like? Is it the prediction, optimization, simulation? Is it the reinforcement learning or not? So we need to map that out, map the high level solution modeling out. And as part of it, we need to identify input and output. So input for us is the data. So we need to assess the data. Do we have enough data? Are the data in a good shape in terms of quality? Do we have all the data that we need or not? And also from the output perspective, we need to analyze what is the expected outlook gonna look like and which are the key metrics that we are looking for. Also, from the users and business engagement perspective, we need to identify who are the end users and who are the key stakeholders. From the integration, we found that this could be one of the challenging areas when we go into the implementation phase. How we kind of integrate the solution and the models in the existing architecture and also business workflow. So both of the elements from the integration perspective. And often we need to sit down with the business and understand, okay, what is the success criteria look like for them? And if we're able to measure the performance of the model and if there is any baseline that we can compare the results with. So those are also critical. Once we kind of map out and address all of these questions, then it's the time, okay, what skills do we need? What tools we need to bring it to the system, what kind of computation resources we need, and so on. And also, what is the cost, and revenue gonna look like? We need to also help our users to identify those. and also from the work plan perspective, how we are going to execute the project. So this was something that we would like to share, that we think it's important that we know when it comes to the execution. So saying that, I will give back to you, Wayne.
Thank you, Farnoush. Sorry, I'm using my phone, so you won't be able to see my, my face here. So as Farnoush was talking about here, in the consulting side, that's the techniques we use, but we're also building 2 products in-house. And one of the products we're working on is called i2 Trader. This is a fintech product. We've been working on this product for the last 2 years now. Financial markets are very difficult to predict. It's pretty much impossible to predict movements in the market. But what we are trying to do is really come up with a very novel way of doing detection and giving recommendations at the right time. So that's really the core foundation of the i2 Trader. It's really focusing on professional traders and also small businesses that are actually trying to play in the marketplace. So we found a niche market that we want to provide these tools using artificial intelligence. So that's our main product. We are currently in the MVP stage development at this point, and we're looking to go into our first release by the end of the year. So for what we're using right now, we're using a different set of techniques, right? So it's mostly either reinforced learning. We have some predictive models. We're also building a custom or our own innovative agent-based kind of operating system, so we can do automated actions as we go there. So those are some of the things that we are just doing within the platform itself. As part of our discussion today, really we wanted to talk to you about how we do data science, how do we do machine learning development within our company. This is something that I think for any startup company or any other organization out there, there's a lot of tools out there. If I draw a diagram, there's so many tools to use out there. So we just wanted to show you the approach we have taken when it comes to how we do development within our organization. So we took a very simple approach to say we're going to go with open source. When we started working, we're mostly working with Microsoft products, and the cost was a bit high for us because we saw our computation cost, development costs just going higher and higher every time. So we took a step back really to focus on open source products. That's what we did. We still use Microsoft products in there. We use Google and also use IBM Cloud at the same time. So now we are really open source, very cloud agnostic, but we can deploy anywhere, we can run anywhere. So really we develop within our local machine, and all the work we do, we run it within a container on our local machine. And then if we need heavy computation or you need to train in a cluster somewhere, we can easily deploy using our CI/CD pipelines. And we create a Docker image, and we register that image in our Docker registry. Right now we're using Docker Hub for that, but you can use any registry you want. And then you can deploy either in a Kubernetes cluster or wherever you want to deploy that to. That's pretty much the approach where we found that is working for many organizations. And this is what we've adopted within the organization. So when we're working, we wanted to really address 4 key areas in model development. The first thing that Farnoush was talking about was we need to ideate, we need to innovate. So that's what you get at the beginning of the project, where you're formulating your hypothesis statements, you're trying to define the problem statement exactly. You're not sure exactly which direction you're gonna go. You can have 5, 6 different ideas. So this is really our experimental stage. So we wanted to have tools that allow us to experiment, allow us to do data wrangling, data managing, all those data extensive stuff to get the right data so we can answer that question. So what we decided really to focus on using Spark and Jupyter notebooks. So that's kind of what the tools we use right now to help us with experimentation. And then once we say now we have an idea of how to solve the problem, so we have done that analytical approach. We know exactly now which direction we're going. Now we start doing model development, and we want to track those experiments. So we want to iteratively go through the modeling exercise, track all the experiments, what we're running on. So for that, we are using MLflow to help us checking sure that our model is going in the right direction. Once we have a good champion model that we like, and say this is the model we like, we can then register that model, tag it as a good model that we want to deploy it. Then we have got different ways, whether we are deploying that in the database or it's running in a Spark cluster, or we're going to expose an API. So we wanted to make sure that we have a nice way of exposing or serving our models. From an API perspective, we are currently using Fast API. Now, AI is a team sport. You can never do that by yourself, right? You have to share, collaborate within a team. That's really what science is about, right? Science is sharing, right? So what we do is really we encourage collaboration throughout the whole process. You know, at the experimental side, we are sharing with our peers, we sprint reviews, we document everything that we're doing. In model development, we document everything in Markdown, documenting everything inside the code, right? But eventually you want to share your work overall. We are using a tool called Streamlit, which is a kind of a Python-based kind of web framework that we can easily publish our thinking, our approach, so that everything is self-contained in a project. So if you're looking at all these concerns, most likely going to have different projects or different ways of doing this. So what we did now is really try to put everything together by using Docker. So I'm going to share my screen now. Hopefully this works. Let me know if you guys can see my VS Code. Can you guys see my code here?
Yes, yeah.
Oh, awesome. So all those things I just talked about, those four concerns that I have, really we put all that together using Docker. I don't have enough time to go through the whole project here, but I'm just going to highlight a few things here. So we have, this is the project. In this project, this is our kind of tutorial project. We're using a hello world iris prediction example that most data scientists, if you're starting into data science, that's what you use. So we use this as a template to teach people and help us through there. So we have got our iris classes here, whereby we are training the model, we are making predictions and all that stuff. This is the way everything is. But we then take everything together through a Docker file. A Docker file kind of prepare the image from with the best image that we have that has got PySpark already built into it. So when you start that base image, you have got Spark underneath it. If you want to use PySpark, it's got some of the best libraries that you have already. Then we package everything using Docker Compose. So in Docker Compose, as I said, we can have this Streamlit container running for the serving our models. Then we've got our main core container that's going to do the training and the deployment. As you can see from this code here, it's just calling an entry point file that's going to either, when you run this, it's going to either run a deployment side or you're only doing training. So it's kind of doing two things at the same time. Then at the same time for experimentation, we are kicking off another notebook, another container that's going to do pretty much start our notebook so we can do experimentation. So all this is just under one project. So when a developer gets this, they check this out, they start working on that project, they've got everything in one project. So all you have to do is, I've already run this project already. You just run the command Docker Compose, which is a very simple command whereby you just pass. If you can see here, just Docker Compose, you pass by the project name and say up, and it'll build the project for you and it'll stand up. So if you're on your machine, normally you have to have a Docker desktop application set up. So if you got your Docker app, you're gonna see now that project running within your machine. This is running on my local host here on my laptop. And then you see now we've got our project setup here, I've got 3 containers running within this environment. So if I go to my experimentation phase, I can easily just, kick off my Jupyter notebook here. So I think I have it already running here. So I go to my Jupyter notebook here. And I have my Jupyter notebook running on my local machine. So here I just ran an example. So you have got PySpark. You can see there's nothing running in my Spark environment, but I just wanted to show an example very quickly that I can run this code just running within the Docker environment, that the container that I just showed you. I will start my Spark context here, and I'm just running a simple function to have calculate pi, right? Then if I go now to my jobs now, I'll see now Spark is actually running within the container, is running that function for me. So this is how we can give data scientists enough compute there to run. When they deploy this to the server, it will run on a much better machine, but they can do a lot of things with Spark and within a Jupyter notebook. And the same code, if we decide to run on our main Spark cluster, the same code will still run exactly the same way. So this is how we do the kind of quickly the managing of experimentation. Then for training, what I'll do here is, let's see if you guys can see what. Right. For training, what we do is really, as you guys seen here, I'm using Fast API. So really, it's a simple process that we use here. We just expose a function that's going to take a trained model, and we expose it, and we expose it as an API. We are using MLflow here, so I won't have time to show you guys everything I'm doing for MLflow tracking. But if I got MLflow, you can see all the experiments that we're tracking very quickly in there. So if I go to my Fast API here, I can easily go to the API, and I can see the predict function that I have there, and quickly I can easily test it and see this is how quickly I've exposed my my model as an API. So if I go to, give me a second, I've got too many windows open. I was trying to hide my IP address for my MLflow. I don't have the IP hidden so far, so I didn't want to show that. But in MLflow, pretty much you'll be able to track every training run that you're doing. You can pretty much see the experiment. You can track any metrics that you want on any accuracy, MSE, or if you have any confusion metrics you want to show there. MLflow allows you to do that. And within MLflow, you can then have, once you have your champion model, you can also do deployment MLflow, but you can register the model and expose it as an API through MLflow. So that's a capability that you have there. So all these things that we're doing within here is really compact in the same environment for a data scientist to start working from end to end without having too many tools that you're working on, so they can really focus on doing the actual work. So the work that you see here, we've published it on our blog. So you find it there. So the blog is live there. I'll put the link there. Is ready to talk about those 4 concerns: experimentation, model development and tracking, model deployment and collaboration. And all this we're using only open source tools. You can run them in your local Docker environment, and you can deploy this wherever you have a machine that's running. You can deploy in Microsoft Azure, AWS, doesn't matter where it is, but it's a much cheaper way of doing ML development. So this is how we're doing, how we do our ML development in Intelius.AI. So we quickly wanted to share that with you as a kind of to advance the practice and to show how we are leveraging open source tools out there. I think that's it from us.
Excellent. Thank you so much, Farnoush and Wayne. So I'm just going to make sure that everybody can unmute themselves. And so now we turn to you, audience, if you have any questions for Wayne and Farnoush of Intelius.AI. I have a question. This is a bit of a more of a question about the inception of this product, about what was that moment where you decided to pursue AI consulting and product management, and when did that start coming to play, and how did these conversations start around how it might be applied?
So Farnoush, should I take that one? I'll take it.
I'll take it. That's fine.
Yeah, that's a very great question. I think for us, really, my experience has been in the oil and gas industry. I've started my career actually in aviation. And then when I was in the US, I was working at a company called Verizon, working mostly with fiber optics. And that's where pretty much I picked up analytics. Well, I came to Canada when I was working for Enbridge, and that's why I got introduced to different techniques around leak detection, analytics within oil and gas. In that exercise, we were solving a lot of data-driven problems in terms of when do we build a new tank, what's the power to run the pipeline. So there were a lot of interesting things we saw there. Key decisions really that needs human in the loop or human in the loop. And from there, that's really the inception of the company to say, you know what, we need to really have something that can help companies make better decisions by using advanced analytics. At that time, really, AI was not a sexy word. We're talking about AI, advanced analytics. That's what we're talking about. But really, that was the inception of Intelius.AI to really drive decision-making based on data. The product itself, it came as an inception, but we're trying to do our own investment when we started working. And as we're making money, we're trying to, let's invest our money in key area, and we're having a hard time doing that. And we realize this is a common problem that's being faced by many, many other small organizations like ourselves. And then that's when the idea came in to say, you know what, we can turn data-driven decisions, artificial intelligence into trading intelligence, really to help people make better decisions. It's not trying to predict the market, but to just help, inform a person to make that better judgment when making that decision to do something.
I can add to that question as well regarding this model deployment solution. We passed the long journey when it comes to the applied AI, especially in the large organization, and when you are having lots of other system, and the integration could be challenging. So we faced many pain points. Like one of them was cost. So I want to make sure that we minimize our costs, especially when you are dealing with building deep learning models and with tons of data. So that was one of the incentives that we have to start working that and sell it to our clients as accelerator tool. So I want to just add that as well.
Excellent. And we have a question from Joseph in the chat, and he asks, how do you charge? And I will add to that question. If somebody would like to connect with the two of you to pursue either a consultation or product development, what's the first step to achieve that?
Do you want me to answer, Wayne?
Yeah, go ahead, please.
Yeah, so we kind of start with free consulting, call. So it's like, just know each other, understand the needs. And often we are going to as well have a few hours of a discovery session to understand in deep what are the requirements, what are the challenges, and how we can understand the customer need in terms of their budget, in terms of their timeline, in terms of all other constraints that they have. And right now, because of COVID, we understand that many businesses are suffering. But for us, we want to make sure that we shape our offers in a way to make sure that we fulfill our need of customers. So open discussion about, okay, this is how much we can afford, or not. But in terms of the charge, we are very flexible. We can work on time or time and material or any other business model. We are very flexible, basically. I know, Wayne, if you want to add anything.
I think you're bang on. We are not trying to be like other big consulting entities. We really want to be a trusted advisor, a partner with the people that we work with. So it's a very tight integration relationship that we want. And whatever we do, we have different models of how do we engage with you. So it's really a collaborative approach. So you can feel that we're in this journey with you. We really want the organization, whoever we're working with, to be self-sufficient. That's our main goal. So when you come, we work with you. It's a two-in-a-box approach to ensure that you become self-sufficient to go forward on your own AI journey. Because really, you need, when you come to these solutions around analytics, you really want this capability to be within your organization or within your company that you're working in, but it's something that's so valuable to you. Because data, really, that's the important thing. Data is the most valuable thing that you're gonna have. Algorithms and tools will always change over time. So really, we're here to help and move that forward, move the needle as we go forward. Another thing we bring to the table is we bring an accelerator. So if you want to start a project and you don't even know how you're going to stand up your architecture, stand up your platform, we bring a set of accelerator tool sets already packaged. So you don't have to spend 3-4 months working on that architecture. It's something that we become free license to use, and can get you going pretty much within a couple of days. And that's another added advantage that we bring to the table when we engage with you.
Excellent. Thanks so much for the questions and for the answers. Any final questions for Intelius.AI? Okay. Well, please join me in giving an applause to Farnoush and Wayne for their presentation. The discussion at this meetup today was fantastic, and it makes us really excited. But with that, we can wrap our February meetup, and of course, this meetup would not exist with the support and success of our community. So let's connect. If you have any questions about the meetup, or if you are interested in presenting at a future meetup, we'd love to hear from you. Again, this meetup will be available on our YouTube page soon, so we encourage you to go on our YouTube and view it. But we also have a lot of content that's worth exploring there. We have more technical presentations from the AI seminars and tea time talks hosted at the University of Alberta, as well as other lectures that we've hosted in the past. But with that said, we do hope to see you again next month at the same time for our March meetup on March 18th. And once again, thank you to our presenters for sharing your time and expertise with us this evening. Wayne, Farnoush, George, do you have any final words or thank yous you would like to say?
No, just it was a pleasure to meet all of you, and thanks for your being patient here with us.
Yes, I echo that. Thank you.
Yeah, thank you. Thank you for such a great opportunity, Amii. Really appreciate it. Thank you so much.
Excellent. Well, we hope to see you all next month, and we wish you all the best until then. Cheers and have a good night.
Cheers. Bye-bye.
Thanks, everyone. Bye.